So guys, welcome to the Triune Physics. Today we'll be treating refraction of light through the rectangular glass prism. Okay, this is the Triune Physics method. We've treated the biblical method. So if you want to understand this fully, please check our videos under this playlist on the refraction of light waves. Now, this is refraction of light through rectangular prism. When we speak about refraction, this is one of the most important topic that you come across both in WAEC and JAM and other examination bodies. So by definition, what is refraction? Refraction is the bending. Please underline the word bending. Refraction is the bending of a light. The bending of a light ray. Are you following? As it crosses. So when light moves from one medium and it enters into another medium, it will bend. So this is what the definition is trying to capture here. So refraction is the bending of a light ray as it crosses the boundary. The boundary is the surface between two media. The plural of medium is media. So between two media of different densities. I hope you are following. Of different densities. So density affects light rays, thus causing a change in its direction. Are you following? So from this, we are using the triune method to explain this. If you check critically from this definition, you see that the triune most important components of these definitions are the bending of a light ray. This is number one. It bends, then it crosses, the crossing of the boundary between two media, and we have different densities. I hope you are following this. So let's quickly use this diagram to explain this. The bending is the refraction. So that's the part that is circled. Okay. Then we have crosses the boundary between two media. So crosses the boundary is the surface of the outline of the prism. Then two media. One, the air. Two, the glass. So that line is the crosses the boundary, is the boundary. Then we have two media, air and glass. Are you here? The plural. So different densities. Air has its own density, glass has its own density. Are you here? So thus causing a change in its direction. So this change in its direction is the bending. Are you following? Is the bending. So the light comes from P, enters through the glass prism, and come out and become S. Are we together? So please, basically, this is the interpretation. So the triune media, are you here? The triune media, number one, we have air. Let's label that as one. Then we have glass, number two. Then we have air, number three. Hope you can see that. Let's circle them. Can you see that? Please understand this concept. Now let's demonstrate refraction. The source of the light is the torch. You can see the light coming in and it has been refracted through the glass prism and it has come out. I hope you have seen that. So for WAEC and JAM candidates, especially WAEC, the first step practically is to draw the outline of the rectangular glass prism. As you can see, we're using the visual method. So imagine this is our glass prism. So what you do, you trace the outline. Are we together? You trace the outline of the rectangular glass prism. And while doing that, you do that quickly and then you do that perfectly so that you can obtain a perfect result. Now, once you are done with the tracing, the next thing is to draw your normal. Well, let's label this as A, B, C, D. Okay, the next step is to draw your normal. Please, if this were to be a practical class, we would have seen the question, so you follow the procedure as stated. Are we together? So this indicates our normal. You can see it's at 90 degree with the interface. It is perpendicular. Then your angle of incidence will be given to you, where you place your pin 1 and your pin 2. Are we together? So you measure the angle from your normal, which is from 90 degrees to your left. Are we together? Then, of course, this ray of light will be refracted, okay? And once it is refracted within the glass, what will happen? It will come out at the other end. So this is the emergent ray. We'll also draw a normal to that, because this is where your pin 3 and your pin 4 will be placed. All together, you can see your N2, your normal, the second normal is also perpendicular to the interface. All together. Then you join the tip between the two. The end of the incident ray to the other end of the emergent ray will be joined together or linked together within the glass prism. And that part is what gives us our refracted ray. Can you see it? So this gives us a refracted ray. And once you measure it from the normal, it gives you a refracted angle. So from here, recall, we've drawn this area, but we are still redrawing this. This is our normal, please take note. Then our emergent ray will be given to us based on our pin 3 and our pin 4. All right, this gives us our emergent ray. Then the angle between gives us our emergent angle. Are we here? So let's begin to label each of these angles as given to us. So this line here indicates our refracted ray. Okay, we're going to write that. That is our refracted ray. Then this is our emergent ray. Right here, these are the triune rays, as you can see from this diagram. Then we have the first one here. This is the first of the triune rays. Recall that the word operates in threes. Okay, then we have this angle, we have the second angle, we have the third angle. We call this the triune angles. We have I, we have R and R are the same. Okay, then we have E. We term this to be the triune angles. Then the ray of light travels towards the same direction, please. So our arrowhead is showing the direction of travel. Are we together? Then what happens? The first ray of the triune ray is the incident ray. Then we have the second ray in the triune rays as the refracted ray. And we have the third ray to be the emergent ray. It is coming out of the glass. So we term that to be the emergent ray. Are we here? Then we have the normal for the first interface and the normal for the second. Then we have O and R as a point of intersection. Then we have P and S. Is that clear? P is the beginning, S is the ending. All together. Then we have the first medium to be air. Okay. Then we have glass as the second medium. Then we have air as a third, based on the emergent ray. All together, which is why if you check critically, you see that I will be equal to E, because it is air and air. Are we together, please? So let's proceed further now. So if this were to be your practical class, you are going to measure these angles, the triune angles, using a protractor, okay? But here we're using the visual ruler to measure that. So you see from 90 degrees, we are having up to 140. So we'll now measure that as our I. Hence, our I is equal to 140 negative 90, so that our I will become 50 degrees. So the idea is 50 degrees. Take note of that. Then we'll do the same thing for the emergent angle, the E there. So you see from 90, we're also having about 140. Hence, our E is equal to 140 negative 90. So that our E will equal 50 degrees. So in most of the cases, your I will be equal to your E. I hope you are following. Even if there are some discrepancies, it will not be greater than 1. Are we here? So please take note of this. Then for you to measure your R, your angle of refraction R, it will give you 125 based on our visual ruler minus 90, so that our R will equal 35 degrees. Are we here? So you can use your protractor to measure all this if this were to be your practical class. Are we together? So with this, we have our triune angles. Are we here? Our triune angles have been gotten. The I, the E, the R. The I is the angle of incidence. The E is the angle of emergence. And then the R is the angle of refraction. So recall that light travels in a straight line, right? So the incident ray is meant to travel this way. So if you observe, you see that there is a deviation. Okay? Then we have what we call lateral displacement. Lateral has to do with straight line, the lateral displacement. How do you get this D? You get it from the point at which your N2 and E meets. So you draw a straight line to meet your supposed incident ray. Are we here? So you measure the distance. So you can see this 1 centimeter, 2 centimeter. This is about 2.3 centimeters. So our D is 2.3 centimeters, which is the lateral displacement. Are we together? Then, not forgetting your angle of deviation based on the incident ray. So let's quickly capture the angle of deviation, okay, between the dotted lines within the prism and the blue line within the prism. It gives us Y. So we're using Y to represent the angle of deviation based on this. So that's that on this episode. Please, by introduction to the definition of refraction using the rectangular glass prism. Do join us, because we'll be solving problems for JAM candidates, and also we'll go into the triangular glass. Connect to our social media handles at PhysicsBible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.